Hello everyone, myself Namita Amrutkar from Abeda Inamdar Senior College. Today we are going to delve into the fantastic world of a linked list, a fundamental data structure in a computer science. Linked list is a linear data structure where each element known as a node contains a piece of data and reference or a link for the next node in the sequence. Unlike array, linked lists do not require contiguous memory allocation. This makes linked lists dynamic in size, allowing them to easily grow or shrink as needed without the need of reallocate or reorganize memory. Additionally, linked lists facilitate easier insertion and deletion. In array, inserting or deleting element involves shifting other element, which can be time consuming. But in linked lists, on the other hand, only require updating a few pointers. Why there is the importance of the linked list? Linked lists are essential in many applications, such as implementing data structure like stack, queue, and graph. We shall learn this concept on a next session. They also form the basis for more complex data structure like hash table and skip list. Here in the slide we have to declare the node, struct node, and there are two members, data and next. Let's go through the basic operation on a single list. Insertion, deletion and traversal. Insertion. To insert a node at the beginning, we simply update the new node's pointer to point to the current head of the list and then update the head to be the new node. To insert at the end, we traverse the list to find the last node and update its pointer to the new node. Inserting at a specific location involves traversing list to find the correct spot and adjusting the pointer accordingly. And if you want to delete a node from the beginning end at a specific position, first we learn about at the beginning. When we want to delete the node from the beginning, update the head to the next node. To delete from the end, we traverse the list to find the second last node and update its pointer to null. Deleting a node from a specific position involves finding the node and update the pointer to bypass it. The next operation we have to perform on a linked list is a traversal. Start the head and follow pointer to visit each node sequentially. To create a single list in C, we first need to initialize the node. A node in a linked list contains data and a pointer to the next node. We start by defining structure for the node and then declare a pointer for the nodes and the head of the linked list. After initializing the node, the next step is to allocate memory for each node using malloc function. We use malloc function to dynamically allocate memory for each node. This is necessary because the size of the linked list can change during runtime. In this code, malloc function memory equivalent to the size of the struct node for each pointer. This memory allocation allows us to store data in this node. Once a memory is allocated, we can assign data value to each node. We assign values to the data part of each node. This step is crucial for storing the actual information that the linked list will manage. Here, one value is assigned to the node number 1, 2 value is assigned to the node number 2 and 3 value is assigned to the node number 3 respectively. In this code, one of next part is connected with the second node, 2 node is connected with the 3 node and after 3 node there is no node, so therefore the next part of the third node is null. Finally, we set the head point to the first node. So I write down here head is equal to 1. This marks the beginning of the linked list. Let's understand about doubly linked list. A doubly linked list is an extension of the singly linked list where each node contains additional pointer which point to the previous node. Thus, each node in a doubly linked list has 3 parts: the data part, next part and the previous pointer. In a singly linked list, there is only 2 parts. We already know data part and next part. The primary benefit of a doubly linked list is the ability to traverse the list in both direction, forward and backward. This bidirectional traversal can be very useful in certain applications. Additionally, deletion operations are more straightforward since we can directly access the previous node. Let's look at the basic operation on doubly linked list, insertion and deletion. To insert a node at the beginning, we update the new node's next pointer to the current head, set the current head pointer to its previous pointer, and then update the head to be the new node. To insert at the end, we traverse to the node at the last node, update its next pointer to the new node, and set the new node's previous point to the last node. Inserting at a specific position involves updating the surrounding node's pointer to include the new node. And suppose you want to delete the node from a doubly linked list. We can delete by three ways: from the beginning, from the end, and from the specific location. First, from the beginning. To delete the node from the beginning, we update head to point to the second node and set its previous pointer to null because second node becomes the first node. To delete from the end, we traverse to the node to the last node, update the second last node next pointer to null. Deleting a node from a specific position involves adjusting the surrounding node's pointer to bypass the node to be deleted. To create doubly linked list in C, we first need to initialize the node. A node in a linked list contains data and a pointer to the next node and also a pointer to the previous node. We start by defining structure for the node and then declare pointers for the node and the head of the linked list and the previous of the node. After initializing the node, the next step is to allocate memory for each node using the malloc function. We use malloc to dynamically allocate memory for each node. This is necessary because the size of the linked list can change during the runtime. We already know that in a singly linked list. We are also doing the same memory allocation by using malloc functions. After that, we have to assign the values to each node. There are three nodes are available, 1, 2 and 3. So we have to assign a value for the first node is 1, second node is 2 and the third node is 3. Now we want to connect first node to the second, second to the third, but also remember that we also connect the previous node. The first node or previous node of the first node is null. Therefore I write down previous of first is equal to null. And the next node of the first is equal to 2. Same for the 2. The previous node of 2 is 1, correct. And the next node is 3. The same for we have to implement for the third node. After the third node, there is no node. Therefore, the next part of the third node is equal to null and previous part is 2. Now we want to save the address of the first node. Head is equal to 1. In that way, we have to create the doubly linked list. Now next type is circular linked list. A circular linked list is a variation where the last node points to the first node, forming a circular structure. This means there is no null reference at the end of the list. Circular linked list can be either singly linked list or doubly linked list. In a singly circular linked list, each node has point to the next node and the last node points back to the first node. In the doubly circular linked list, each node has point to the both next and previous node and the both last node next point to the first node's previous pointer connect to the ends. Benefit of a circular linked list. Circular linked lists are useful for application requiring continuous or cyclic traversal, such as implementing round-robin scheduling algorithm where each process gets an equal share of CPU time. They also help in managing resources in a circular manner, ensuring fair allocation. Let's go through the operation of a circular linked list: insertion and deletion. To insert a node at the beginning, we update the new node pointer point to the current head and then update the last node pointer to the new head. To insert at the end, we traverse to the last node, updates pointer to the new node and then set to the new node's pointer to the head. Inserting at a specific involves traversing to the position and adjust the pointer while maintaining the circular structure. To delete the node from a circular linked list. To delete a node from the beginning, we update the head to point to the next node and adjust the last node pointer to point to the new head. To delete from the end, we travel to the second last node and update its pointer to the head because we want to attach it to the first node. Deleting a node from a specific position involves adjusting the pointer of surrounding node while ensuring the list remain circular. Circular linked lists are ideal for scenario where resources need by managing in a cyclic manner, such as in round-robin scheduling. Now let's start implementation of a circular linked list. We start by defining structure for the node and then declare pointer for the nodes and the head of the linked list. After initializing the node, the next step is to allocate memory for each node using malloc function. We use malloc dynamically allocate memory for each node. Therefore, I write down the node 1 is equal to malloc function and whatever the size of that particular node will be allocated for it. Same for the second and the third node. After that, once memory is allocated, we can assign data value to each node. The first node, the value we have to assign 1, second node 2 and third node is 3. Now we want to connect the first node with the second, second with the third. Therefore, write down the first of next part is equal to 2, the second node next part is 3, third node next part is 1. It is a circular, therefore the last part is connected with the first. And now after that, we have to save the address of the first node in the head by writing the instruction head is equal to 1. In that way, we have to implement the circular linked list. In this session, we learn singly linked list, doubly linked list and circular linked list. Singly linked list has only 2 parts, the data part and the next part. Doubly linked list has 3 parts, data part, next part and the previous part. In a circular linked list, have connect last node to the first node. Thank you for your attention.